I put the title as The Light, the Universe and Everything, not just because it's kind of a joke, but because everything evolved under the sun. And when we bring animals into captivity, for some peculiar reason, because we're humans, we want to optimise what we can provide, but we imagine that we can take things away without any consequence. And one of the things that as humans we've done to ourselves is we've taken away the sun. We live indoors, we live in caves with UV blocking windows, and we kind of imagine that we can take away the sun and get away with it. And by and large we do. We're all reasonably healthy and whatever. And what I'm going to try and show you is that I don't really think that we're doing the right thing by taking them away from the sun. But unfortunately it's really hard to reproduce the sun indoors. And all we can do is a kind of a best attempt at it, which is why we seem to need all these different products to do that. Well, first of all, what is sunlight? Well, we've already covered a little bit of this, and it's the spectrums right the way through from ultraviolet to infrared, and it's normally shown as a spectrum. We've talked about these nanometers, and basically they're just a physicist's way of numbering colours, if you like. So if it's, for example, 600 is yellow, 600 nanometers comes out as yellow, and 200 nanometers is in UVC. So it's just numbers, really. And animals use the whole solar spectrum, and the Earth's atmosphere blocks off the nasty stuff, the UVC and the short wavelength UVB, which is why we mustn't get them in our reptile lamps, and the rest of the sunlight, and of course it goes into long infrared here, but most of the sunlight is in the shorter wavelengths of infrared, which is why things like the ceramic tubes, which don't start emitting until way down, are not like sunlight at all, which is what Ron was saying. And life makes use of the whole lot. It's evolved under it. Evolution works to make things optimal for their environment, and therefore the environment of the animal is going to be optimal in its natural environment when the weather's good and things are going well. So the whole solar spectrum is used, and they need all of that at the right intensity. So the animals that live in the shade obviously don't need the intensity that animals that live in the sun. And also the right photoperiod. Well, Ron's talked about the timings of the different seasons. And my diagram, up until I listened to Ron, was like this, that you could partition the light in your brain, if you like, to say that thermoregulation was to do with the infrared, and then vision and activity levels were to do with the visible light, and the UV was the vitamin D side of things. But I'm now going to change that, because I'm now going to say that it's solar energy that's producing the thermoregulation, because the visible light, the UVA, they all contribute to the energy that we absorb and turn into heat. And obviously we all know about these gradients, the heat gradient that we use, but also the light gradient from sun to shade, because it follows. If you're in the sun, you're getting all the energy from the sun, so obviously you're going to get the basking areas, and then you've got the shade, which is the cooler areas. And so it's light, UV and heat all together. And animals live in the different parts of the gradient, but basically they can always move from a full sun gradient to a full shade gradient, and they're very sensitive to that. They're very, very good at finding the level of light, heat and UVA and UV that they need. So how do they get up in the morning? What's the sort of trigger? Well, if your core body temperature, which has been very well studied in laboratories, is say 25 to 27, they need to get their bodies up to that temperature for their optimum activity levels. And then for bearded dragons it's different, it's higher, and each species has their own tested in a lab optimum temperature, and it can be to do with their stage of their life cycle, or it can be their stage of their digestion, all this sort of thing. But then when we look at the environment, this doesn't match, because for example, let's look at the leopard geckos. Their optimum temperature is 25 to 27, but here's the Afghanistan desert, and this is where they live, in the little rock crevices and things, and at night it drops a heck of a lot below that, and in the day it goes way above it. So what are they doing? Well, obviously you can say, well, they're basking to get warm, but this is one I hear all the time. Some are nocturnal, some never see daylight. Well, do they really never see daylight? If you look at some of these nocturnal animals, I mean, that animal is experiencing daylight. It may not be in sunlight, it's certainly in daylight, and daylight contains UV. And that's one of my leopard geckos. And he's certainly in daylight, and he's certainly basking. Okay, he's not in the sun, but in the wild, presumably, they behave like that. And the AHH have been kind of using this word kathemeral, which is a brilliant word. It means that they can be active at any time of the day, but obviously these species have their primary activity at night, but occasionally come out in the day, whereas these ones have their primary activity in the day and tend to sleep at night. But they don't just fast to get warm. That's a big mythology which we all kind of believe, but it's not necessarily true. But of course they've got to get warm because that's vital. And they need to get warm, we all know, because if they don't, if they're at low temperatures, their heart rate will slow, they become less agile, they can't get their prey, they can't respond quickly enough to predators, they don't digest properly, their immune system starts to crash and their growth rate slows. So you've got to get them up to the right temperature. So they've got to find a heat source. And it's got to be at least equal, but mostly above the desired temperature. But also, they've got to have what they call heat sinks. And a heat sink is a cooler area where they will lose heat to that environment. And so they will move in between the two, and that's the shuttle basking, which we're kind of familiar with. So how does basking work? Well, here's my bearded dragon, Hog. He's one of my favourites. He's my first beardie. And the short wavelength infrared, as Rom has told us in quite a lot of detail, will go right through into his body. And I'm now going to add to this diagram. You haven't seen this before. I made this after I talked to Rom. We're going to put some extra energy in from the visible light, which won't necessarily penetrate the body as deeply, but it will certainly penetrate, particularly the red, which will go quite deeply. But also remember, the sun warms the environment, so we've got the infrared heating up the ground, and in the wild, that ground will then re-radiate these very long wavelengths, but they don't penetrate the skin much at all. They just put the energy onto the surface of the skin, and then it diffuses through, so they're getting warmth, but they're getting it directly on the skin rather than going through into the body. And then you've got, of course, if the animal's lying on something warm, you've got a different method of heat transfer, which is just conduction. If you put your hand on something warm, there's no radiation, there's no infrared, it's just the warmth going straight through into your skin. So they've got that as well on the surfaces they're lying on. So that's how heat gets to a lizard or any reptile, and incandescent lamps will produce this, as Ron has eloquently said earlier on. And your ceramic heaters and heat mats, not necessarily under the animal, because we often put them up here, but they will provide this long wavelength stuff which will hit the skin and be absorbed by the skin. So it's a different method of heating from a lamp. And of course, if you're using things like heat mats or the warm substrate, you've got the contact surface as well. And we've all seen lizards lying flat out on a warm rock. The heat is coming out of the rock, but also it's coming down mostly from above. Now, these short wavelength infrared heaters, which Ron's shown us, they don't have the visible light, but they've got the short wavelength infrared, so they're not using this part of the spectrum as much as this. But basically, it's the same type of energy that's included in the lamps, but without the light bit, which is why you need the light bit for the bright light to be added. But measuring temperature, as Ron was indicating, is really tricky, because what are you measuring? Now, our old-fashioned these little stickers that people buy and put on the back of the Viv, and these little dial thermometers that you can buy and stick on the back of the Viv, they're measuring the air temperature, because they're not in your basking area, they're stuck on the wall. But the air temperature can be so different from the temperature of the surface or the temperature of the skin. For example, this is a little tortoise in the Mediterranean. I was with Andy Highfield and we went looking, found this little chap, and the air temperature is 27.6, but the temperature of the ground is 40.6, and that's a massive big difference. But if you take the temperature of the animal, it's 40.2. So he's absorbing heat from the radiation, getting his temperature up a heck of a lot higher than the air. And that's how basking works. So I went to Kruger on a wonderful holiday, and the ground was 64.3. Now you all know that if you put your hand on hot sand, like Ron said, the temperature's really hot. And the air temperature was only 27, so you've got this huge discrepancy. And keepers may not realise that. It's really important that if you're going to measure the temperature to get it safe for your basking spot, you're not going to measure the temperature of the air, you're going to measure the temperature of the substrate. And that's why everybody, if you're buying a new lizard, please get yourself a little one of these temperature guns, you know, like the fancy ones that look like guns or ones that look like that, because then you can just simply go like that and check the temperatures. And these are just taken to check the cool zone, because that is the air temperature. There's no radiation hitting the cool zone, so it'll be the same temperature as the surrounding soil and whatever that hasn't been heated by a lamp. Well, what temperatures do we want? There's loads of stuff about thermoregulation that's been published for generations, and a lot of the books will pick up on that and tell you what the species needs. But of course, remember, it will need a higher basking temperature than its optimum because it's got a bask. So we've got a beardie. We want to get him to 34 to 35. That's his core temperature. Every morning he wants to get to that. So your heat source could be have a surface temperature of 40 to 45, because when he's under that, he's going to absorb lots of infrared. But he's also got to have a cool zone where he can walk to let himself cool down. So because he doesn't want to sit at that temperature, he wants to get himself sort of between the two. But do remember that if the substrate, you're going to try and measure, try and get the temperature right for him, but it depends on what you're measuring. If you've got brown substrate there, or you've got white sand or black sand, you're going to get very different readings. I went up on the Blorenge, which is just above where we live in South Wales, in January, and there was snow still left in pockets on the ground, and the air temperature was 1.4 centigrade, so it's blooming cold. And there was little patches that were even colder where the sun hadn't reached. And I took the air temperature, and then I used my little FLIR and I took some other temperatures, and I discovered something really interesting, that where the snow was, it was minus 0.4 because it was still icy and in the shade. But on the white objects, they'd absorbed a bit of sun, so their temperature had gone up to 10. But on the black objects, the soil, old molehill, gone up to 17. Well, 17 degrees centigrade when the air temperature is the air temperature is 1. That's another big difference to kind of bear in mind. So you can see there's big differences between the rock and the soil, white and brown. And it's the same if you do the tests. These are tests I do on heat lamps. I'm not employed by any, and what I do is I put, for example, testing heat lamps, I've got little blocks, because you've got to do it practically, and my black blocks, because they're absorbing visible light as well as infrared, they get a heck of a lot hotter than the cold ones. There's 9 degrees difference in that, so that would be like a basking one, but that one's too cold. So you've got to remember that if you've got your pale substrate, you find it's not as good for testing your basking temperatures. Just be a bit careful. And it's terribly crude, but I'm just going to suggest there's kind of to get a feel for it of what the animal will do. Why not use, for your lamp testing at least, something mid-brown to test your lamps with, just a practical thing. And also do remember that if the animal's 6 inches tall, then it's going to be that much closer to the lamp. So when you're testing the basking spot temperature, put a bit of wood or something that's the same height as the reptile under the lamp, and leave it for at least 2 or 3 hours to warm up properly, and make it sure it's at the reptile height, because that's going to be a lot cooler than it is up there. Just practical stuff.
So just as a quick question,
Yeah.
just out of curiosity actually, are those blocks top ones look connected with the bottom ones don't? I'm assuming they're all individual blocks that you don't get heat transfer across.
They're little blocks of wood.
Just so you don't get heat transfer across from one to the other.
It obviously doesn't, because of the huge temperature differences.
Yeah.
So and I aim the little spot on the meter at the little tiny dots in the middle of each one. So I aim it at that dot and that dot and that dot. Okay. It's the best. It's crude. It's really crude, and it's not scientific because the reptile isn't black, light brown or white. I mean, it's just to give a graph of the sort of temperatures you get under the lamps. So it's not really very scientific, but it's good enough to give you an idea of whether the lamp's any good. Because if you never get above 30 degrees with some of these lamps, you won't, then you think, well, that's no good. Can't use that. It needs more of them or whatever. So that's why I tested those. But do be careful about overheating. I mean, I don't think I need to tell anyone here this, but I tell beginners this because they don't know. If the preferred body temperature is 34 to 35, it will bask with a surface temperature of 46. That's absolutely fine. But if the air temperature ever reached 46, that would be dead in 10 minutes if it couldn't escape the heat, because as soon as its body reaches 46 degrees, it's dead. All its enzymes get killed and it's just dead. And reptiles are kind of prone to overheating like that. So you must have a gradient, you must be able to get out of the heat, and you mustn't overheat them. And so my big thing for all beginners is buy a thermostat. For heaven's sake, buy a thermostat. Okay. But also, you've got a risk of burning. Someone mentioned this in the talk. They said, well, you do have to have a big enough basking spot, and that's really vital. This was taken years and years ago, about 10, 15 years ago, at one of the zoos. And you can see that this sulcata is far too close to this lamp, but mainly the lamp's got such a small beam that his head and his feet are just not reaching the temperature, and it's all just burning his skull, burning his carrot, and you just have to watch that the beam is big enough, and it's so easy to do. You just get a piece of card or a piece of paper, and you just hold it under the light, and you see what size the beam is at the level you want. That's a nice big one, whereas this one's, I don't know, probably a bit small. This is a nice big open beam, there's no sort of focus. These are actually quite good, these are all floods. But if you ever see a spot, actually I think I've got a slide of that. Yeah. Oh no, it'll come up in a minute. This is Andy Highfield's slide. Some of you might even have seen this on the website. This is in the sunlight. The whole tortoise is pretty much within a degree or two of the same temperature. The whole body is irradiated. This is a heat lamp. And you can see that, look, you've got a hot spot on top of him, and his little head and his little feet are way, way down, 15 degrees instead of 30. And we do that too much. If the basking spot's too small, I've seen tortoise tables for sale with a desk lamp over the end of the tortoise table. And it's going to produce a little spot like that. The poor little tortoise is going to be there forever, sitting there trying to get warm while its shell is burning on top. And that's the classic. That's what they call a basking spotlight. And look, there's a horrible little spot that's not even 5 centimetres in diameter, in circumference. What am I talking about? Radius. It's not 5 centimetres in radius. Whereas a wide flood beam will light the whole area. So please make your basking spots big enough. And the easy way to do it with a really big animal is to have 2 or 3 or even 4 of the little ones spread out on a triangle or on the sides of a square. And then you're lighting a bigger area with a gentle light instead of massive great thing making a big hot spot underneath. So it's really not hard.
So how do they make the difference between a wide flood beam and a spot beam? Is it just the angle of the reflector of the ball?
Yes, it's partly that. It's partly whether there's a reflector. Some of these have got quite powerful reflectors, but actually this is a flood because if you look at the little halogen, it's got a misty sort of a, what do you call it, a frosting on the actual halogen capsule, and you'll find that some of these bulbs, this one hasn't, so this one is likely to, if it had a reflector it would make a spot beam, whereas, where's that Arcadia one we had? There was quite one that had a good frosted face, and then I got it out. But there's one with a frosted face, and you can see the whole of the lamp is, like this one, you can see it's got that, you know that opal over it?
Yeah.
That diffuses the light completely, spreads it. Pearl, that's it. If you put a pearl coating on them, then it will spread the light like crazy, and it will make a huge wide beam, and the reflector will as well. You can get wide reflectors. Those PAR 38s have got reasonably wide beams because of the shape of the reflector. They don't actually have the pearl coating. Mercury vapor lamps. I did think about bringing mercury vapor lamps because there's 3 sorts. There's the ones with pearl, and they produce a wide beam, like a big circle of light. There's the PAR mercury vapours, which produce a medium to narrow beam, and there's the dreadful Chinese things that have got completely clear glass faces, and a little glass, you can actually see the little, the innards and the arc lamp, and they produce a spot that's like a little tiny thing about as big as that, of really bright light and really intense UV, and they're horrible, because you can't get anything like that. Even worse than that. They get rejected if I get test them. So basically it's the same sort of idea. A spot lamp will do that. A single flood may be enough, but 2 or 3 or 4 make a bigger and bigger beam. It's kind of sensible, but for some reason we don't talk about it. So, to summarise the thermoregulation, research the gradient, know what temperature you're aiming for, provide your short wavelength infrared and your visible light from above, so your basking lamps above. If you need extra warmth, you can provide long wavelength infrared from the side or below, and that's your heat mats, your ceramic heaters, and make sure the basking area is big enough. So we can summarise that by saying there's your heat gradient, there's your sunlight, let's put the bulbs up there to produce that. So now we move on to the light. Now the light is 2 things, it's the vision and it's the activity levels. And every animal on the planet experiences day and night. The nocturnal animals experience day and night exactly the same as the daytime animals, and that's something we forget. We think, oh, nocturnal animals, they live in the dark. Well, they don't live in the dark, they live in day and night, but they come out in the dark, but they can see daylight. They can nearly always tell whether it's day or night. If they lived in the dark completely, they wouldn't know if it's day or night, would they? So it's kind of logical that they should have daylight as well in their environment when we put them in a tank. And that's quite new to a lot of reptile keepers, because most animals will adapt to the daylight in the room. So you think, well, it doesn't need light in the tank. But if you put light in the tank, you're giving it more what you would get in the wild. And first of all, there's the vision. Now, most reptiles have very good vision, and they use all the wavelengths from UVA right through to red. Some of them can see different colours because they've got different receptors. Some of them are colourblind, as Ron was saying, but they can still see the light and they can see the wavelengths. It may not look coloured to them, but they'll see it. Humans have got the 3 cones, the blue, the green, and what they call the red cone, but actually it's kind of orange. And they can see those different colours as 3 peaks. The turtle, we looked at, what was your species you looked at? It was chameleon, wasn't it?
Yeah.
Turtles also have this cone for the UVA, so that's part of their colour, and the blue and the green and the red, and their red actually goes into short wavelength. We can't see what they can see. So they've got a wider spectrum, and I think we've covered that pretty well. So. But it is just worth thinking that if you haven't got any of one colour, things look funny. I can't take away UVA and show you what that looks like because I can't see it. But I can show you what it looks like if I take red away, and it makes the red berries look like that. So if we took red out of our world, it would look like that. What does it look like when we take UVA out of our reptiles' world? It does something very odd to their colour perception. And lots of reptiles have these markings. Now, those look blue to us, but actually they're UVA reflected. And the animals who look for that, they can see it. And there's a lot of UVA reflected off these blue plants. So you really do need to get a full spectrum light that's got some UVA in it to give them natural colour. But one thing I see a lot of still is people using coloured lamps, like red for basking lights, or green, or moonlight blue. You've all seen the LEDs with the bright colours. But if you have only one colour, you're completely colourblind apart from that one colour. Because if you try it, you don't believe me, try it, you cannot see any other colour except red and black if you have a red light, because there's nothing else for your eye to respond to. So please don't use red lights for night lights or basking lights, because you're destroying the animal's colour vision. And funny enough, nocturnal geckos, for example, have extremely good colour vision in the UVA and blue wavelengths, so it kind of mix it up. But there's something else that light does. Light is really important, as Rom's been pointing out, for what we call non-visual perception. It's when we kind of know when it's morning, we kind of know when it's afternoon, and we can do that, and we're really not good at it. Animals can tell exactly what time of day it is, not just by their internal body clocks, but by the fact of their perception of the light. And how it works is quite interesting. Reptiles are particularly good at it. They have to be, because they've got to use the light for basking, use the sunlight for basking. And the light doesn't just go in their eyes. That's the extraordinary thing. It goes in their eyes, but also, if they've got a third eye, it will go through that. And their third eye is very sensitive to the changes in light between green and blue. And the amount of blue in the sunlight changes with the time of day. There's always more green at dawn and more blue at the middle of the day, because as the sun rises, you get the shorter wavelengths. And they can monitor that with the third eye. But also, the light penetrates the skull. How many of you have looked through a leopard gecko and seen through its eye, through its ears? And you can look at the light coming through one side and the other. And the light is bathing its brain as it goes through. So you've got the light not just going through the head, but also through the little skull, but also through the ears. The brain is lit up. And if we just go into the brain, I've got this little diagram that goes through the skull of this iguana, you can see that this is the brain of the reptile. And you've got all these inputs for light. So you've got light going to the lateral eyes, that's the eyes that we use to see. And then you've got light going through the parietal eye, the third eye, and you've got light hitting the brain. And these little deep brain photoreceptors at the bottom of the brain, which are sensitive to light, just like the back of our eyes. And all this information from this light, the different wavelengths of light, it reaches something called the suprachiasmatic nuclei, or SCN. And that is our timekeeper. We have one, they have one, most vertebrates have this little part of the brain that keeps our body clocks going. And it feeds to the pineal, which produces all these hormones which keep our bodies going and keeps our hormones up to the right levels. And it's called the neuroendocrine network. And it's the light, it's altering the production of hormones in the body clocks, and it sets it every day. So that's why you get jet lag, because your dawn and your body clock is out of sync when you've moved to a different part of the world. And it takes about 3 weeks to readjust your body clocks because of dawn and dusk, and that's how it works. So you've got to have, for a reptile, you've got to have the light not just bright enough for it to see by, but also bright enough for it to stimulate the brain. And because the eyes will, your pupil will constrict and adjust the amount of light that reaches your eyes for vision, the pupil bit isn't as good at telling the animal whether it's really bright or not. It's the stuff that goes through its head that tells it how bright it is. So that's why if you have dim light for an animal that expects to see bright sunlight, its body clocks may not be completely attuned in the same way they would if you have the really bright basking light. And that's a really good reason for having super bright lights. So how bright does it have to be? Now this is the big question, because I can't answer this, and I don't know if anyone else can either. But you can measure it with a lux meter, and what you discover, this is my little plot of the 21st of June, quite a few years ago now, God, 11 years ago, but anyway, it still works. And I discovered that after sunrise, 5 minutes after sunrise, I was getting 3,300 lux. And then it gradually went up on a clear sky to way over 100,000 lux. That's a lot of light by about 7:30, 8:30, 9 o'clock in the morning. Then, of course, the clouds come over and it goes down to about 40,000 lux. And then it goes up again and it's sunny again. And then it starts raining in the evening and then sunset and it goes down. And just before sunset, it was only just over 1,000 lux. Now, offices, they say 1,000 lux is a really good working light. But actually, it's 2 minutes before sunset. And that's why if you go out in the sun and you come back in, for a few seconds, you can't see anything in a well-lit room because your eyes are so used to this really bright lighthouse light. Well, if we put a UV tube in, a little tube like this one, that will produce 480 lux a tenth away. So you can see that's way, way lower than dawn light. And we've been giving our animals that for years. We put a little tube in for a snake or for something like that, or a gecko. We think, oh, there's loads of light in there. Well, actually there's not. If you put an incandescent lamp in, you can get up to 12,000, which is like, oh, I don't know, about a quarter of an hour later. You can put mercury vapour lamps in, you can get a little bit further up. But really, if you want sunlight, you've really got to go for something like a metal halide, where the light is much, much brighter, and you can get up to sunlight levels with a good metal halide. And I haven't got a slide for it, but you can now start to do that with some of the LEDs, like the Jungle Dawns, as long as you get them at the right distance. And I think that technology is going to improve, don't you, Rob?
Absolutely.
I think it is.
Yeah.
It's going to get better and better. And the other problem is that we tend to put the bright light at one end, but we don't bother to light the other end. So you get these horrible sort of dingy, gloomy bits at the others in the dark. But what you really need to do is to light up the whole viv and just have one part which is really bright for the basking, but the rest has to be good lit as well. And then, of course, you'll get your gradient from warm to cool, but also from bright to not quite so bright. And that's more like daylight. So, for example, you can have it from above as well as from the side. So you've got the warmer area of your arboreal animals, and then it goes cooler and darker lower down. So now we've got that area covered. We've got the heat, and we've also got a light gradient, and you can see it's pretty much the same as the heat gradient. So we can do that with the light bulbs. And now we get on to the difficult stuff, the UV. So I hope I'm not boring you, because this is the good stuff. Right, do all reptiles really need UV? How many of you have asked that question? Yeah, some people have, and I think you're all not being quite honest if you don't say you've wondered about this. Well, I'm not going to use that word need, I'm going to say benefit from, because it's absolutely unquestionable that this gentleman here is right, that people have reared animals without UVB very successfully for generations. What I want to show you is that actually they'll benefit from it if you can provide it. You can provide vitamin D orally, and a lot of species will actually survive quite well with it, without it, just orally. A lot of species can manage their calcium metabolism without much vitamin D at all. They can actually absorb the calcium, and that side of the metabolism can be fine. But if you give them the UVB and the bright light and all other things, then there are other benefits.
Question about vitamin D supplementation.
Yeah.
You said about orally supplementing it. How do you know how much to orally supplement so you don't over-supplement?
You have no idea. And neither do the researchers, and that's the hilarious thing. I've got papers that I can show you where some have grossly overdosed and some have grossly underdosed, and they all have these really complicated calculations as to how they worked out how much to give. No one knows, and that's the big problem. In fact, it's really difficult to work out how much humans should get. So I'd like to just talk about the UV, because this is we don't know much about this either, but this is kind of important because the sun is producing it. So
the
it's
D3, vitamin D3, if you overdose it, you actually end up with the opposite result that you're looking for, is rickets over time.
Yeah, you get a
It pulls
different.
the calcium away from the bone.
You get a different problem, and it doesn't help at all. Yeah. It's not quite the same as rickets, but it gives you a crippled animal, and it'll give them kidney failure as well.
Yeah.
But and in fact, it's the kidney failure that leads to the rickets. It's one of those funny things. It kills the kidneys, and then the kidneys can't compensate for it. But let's have a look. The UVB. Everyone talks about the vitamin D, and it's those little tiny wavelengths at the bottom of the spectrum, 280 to 315. But warmth is needed for the vitamin D process. So cold skin, not so good, very, very slow. Warm animal, much faster. And also, in the sunlight, there's this wonderful control mechanism that the slightly shorter wavelengths add to the picture by removing from the skin excess. If the animal hasn't absorbed it and gone into the bloodstream, those wavelengths will destroy it. So that you shouldn't be able to overdose in sunlight with vitamin D. They won't get an overdose of vitamin D if they're out in the sun, because the sun itself will stop that overproduction. I won't go into it here, but I do just want to flag up that this works in sunlight. If you alter the spectrum and you take away certain wavelengths, particularly slightly longer ones, you could, in theory, get overproduction of vitamin D in the skin. And there are a few examples which I'm trying to work on at the moment where people have found very high levels of vitamin D in animals under certain lamps with certain spectra. But it's all research. It's not. No one knows, and no one's seen vitamin D poisoning from lamps. No one. So that's a very good thing. But UV also has other effects. UV isn't just for the vitamin D, and I've got this little sort of thing I run through to try and explain this. UVB has direct local effects, the UV, not the vitamin D. And that is, it's bactericidal, we talked about that with Ron. It actually alters the immune system in the skin. It affects the white blood cells, the lymphocytes, stimulates them to attack anything invading. It also, as we know from tanning, it increases the pigment-producing cells, the melanocytes, which is why a lot of people notice their animals are getting much stronger colours when they're under UV light. It's not that the light is different, it's that the light's doing something to the skin. Happiness. We all know that people smile in the sun, and there is a physiological reason. It does produce beta endorphins, which makes us feel happy. Whether it does in reptiles, I have no idea, but I can't see why it wouldn't. And also, of course, vitamin D synthesis. So let's look at the vitamin D synthesis. UV hits natural cholesterols in the skin, and they are converted by the UV, no enzymes, nothing, it's just a conversion that happens in chemistry to a thing called pre-D3. And if you warm the pre-D3, it turns into vitamin D. You can do it in a test tube, it just does. And that vitamin D isn't a vitamin, it's actually a pre-hormone, it's a hormone, it turns into a hormone. And how it works in the skin, this is just in the skin cells. The cells take it up and they hydroxylate it. They add this 25-hydroxy, so it's a slightly different chemical. And they have another enzyme which then converts it to 1,25-hydroxy-D, and that is an active hormone. And inside a cell, it affects the DNA. It actually creates the change in DNA which produces different proteins. It activates the DNA. So you get what's called gene transcription, which means the genes start making proteins. And also it signals to the cells, the membranes will change so they actually interact with each other. So that's what's happening in the skin when you're in sunlight. And it also causes the cells to produce an antibacterial, and it increases their permeability reinforcement so they don't let things through so much. And also it controls cell division. That's been known for a long time. If anyone's had psoriasis, you know that sometimes I put you under UV light. And the reason it works is that it stops, it dampens down your cell division. So it's stopping the cells becoming too thick and too dense and causing psoriasis. And it does more to the immune system. So basically that's more skin health than vitamin D on top of what the UVB itself has done. Now I'm not saying UVB doesn't damage the skin, because excess certainly does. It damages the DNA, and if you're overexposed, it can cause the skin cancer. But this is going on at the same time. So the right dose is much safer, but the wrong dose can cause harm. It's like anything else. Sorry, there's a question at the back.
No, I've got psoriasis.
Sorry?
I've got psoriasis.
You have?
I've got psoriatic arthritis.
Oh, Crohn's.
Yeah.
I think you might need some vitamin D. I think you might need some vitamin D. Anyway, let's quickly move on. And, not ignoring you, but I think actually we've got something here. Then, of course, the vitamin D doesn't stay in the skin. It goes into the body. And a lot of it goes to the liver. And the liver does that same conversion, turns it to 25-hydroxy-D3 and releases it into the blood. And that's a very stable form. It's not destroyed by sunlight. So it can go around the body quite safely. It can go through the skin. It won't get broken down by the sun. And that's what we test for. If you have your animal tested for vitamin D, they look for that. They look for this 25-hydroxy-D. And a small amount of that is needed every day for the calcium metabolism. This is what, if you don't have it, causes metabolic bone disorder. Because what happens is this 25-hydroxy-D goes to your kidneys, or their kidneys, and they convert it to the active hormone, and that is the endocrine hormone which controls calcium metabolism. And how it does it is it enables the gut to take up calcium, and it enables the bone to lay it down, so you get bone development. And also, calcium is absolutely vital for muscles. If you have calcium deficiency, not only do your bones start to have problems, but also you get that twitching. You know those iguanas that start twitching, they haven't got enough calcium. It affects their growth, partly because of the bones, but partly because of the muscle weaknesses. And of course, calcium is absolutely vital for reproduction, for egg yolk, to supply the baby, for the eggshells, so basically reproduction. So that's the classic pathway, and that's what I was taught at vet school, and that's all anyone knew about it until about 10, 15 years ago. And then they started discovering this thing about what's going on inside cells. And what they said, well, you can put the vitamin D in the diet, and you can keep the animal going, you can get the calcium metabolism beautiful. But is there enough? Well, if there's a bit more, if you get, that's keeping them going, and it will die if it doesn't get enough of that vitamin D that way. But if you give it more, what happens to the excess? Because the 25-hydroxy-D doesn't need a lot for that. And what happens is it goes into the circulation, and the circulation levels rise, and then things that are not life-threatening but are good will start to happen. And the latest theory is also that the vitamin D, before it's converted by the liver, is also important in this. And it goes into the cells of all the body's organs. They all have these vitamin D receptors. And no one had ever worked out what they were for. And they're just beginning to work it out, because what happens is that all the cells can start turning it into the hormone, the active hormone, and then start doing all this gene transcription. And the signalling that was going on in the skin is also happening throughout the whole body with enough vitamin D. And it controls, they've now got studies with humans, over 2,000 genes are responding to vitamin D. Well, that's just completely blown all this stuff out of the water, and there's thousands of papers being published. There's no way to keep up with them, mainly in human stuff, because people just don't care about our reptiles. But surely, if it's doing that, it's got all these things that's happening with this vitamin D, we do need enough of it. So you've got some in the brain, you've got some in all the organs, and you've got this little tiny bit that's keeping the calcium going. But also, you've got this visible light, and this visible light's doing this neuroendocrine network stuff, which is all these hormones, again, which are affecting all these other organs. So you can sum up the whole thing by saying, maybe I need some sunlight. And that's my theory. And I think we should just briefly look at this metabolic bone disorder. We've got time, I think we've got time. It's supposed to be one of the commonest conditions that reptile vets see. And that's a tragedy, because you only need a tiny weeny bit of the vitamin D to prevent it. And you've all seen these pathetic little souls, and they're going to die because they won't recover. They're just ruined. And you can probably keep some of them alive, but some of them it's not even fair to keep them alive. And this doesn't happen in the wild. It's just unknown in wild animals. And it's unknown because UVB doesn't go through glass, it's not produced by ordinary light bulbs, so it's a disease of indoor animals and humans. And this is the sobering bit that I just feel I have to put in every talk. In the late 1800s, they said up to a third of children in Britain could be shown to have active rickets. They were metabolic bone disease in these kids. But about 7 years ago, they started noticing that there was rickets coming in kids in Southampton and also anywhere in Britain. 20% of the children that seemed to have some sort of bone problems actually had rickets. And this chap said it was like 17th century England. And, well, what? You know, what's happening? What are we doing if they're so vitamin D deficient they're getting rickets? But they've now discovered that if you blood test human beings, industrialised countries, humans are vitamin D deficient. This is a graph which showed that they tested 15,000 people in America, and they reckon that if you have a healthy level, then your parathyroid hormone, the one that reacts if you're starting to need to lose bone structure to build up the calcium in your blood, is normal, it's minimal. 74% of people had lower levels than they would need to suppress that uptake of calcium from bones. So 74% are either insufficient or deficient. Now, that sounds like a chart, just a graph. So I decided I was going to test my whole family. So I spent rather a lot of money, and I bought all these finger prick blood tests, and I made my family prick their fingers. And I discovered that my husband had 10.3. So he was already way down in vitamin D insufficiency. And then I tested my son, who was a teenager at that time, he's now grown up, and his was 8.8, so if he'd been a baby, he would probably have had rickets. That was pretty scary because he spent all his time in a black room watching video games. So it wasn't just a question of sending him out in the sun, we had vitamin supplements. Well, why are we so deficient? And it's pretty obvious why. If those of you who've got white Caucasian skin, which is probably most of us in this room, we evolved thousands of years ago as farmers in this latitude. So we evolved skin that was used to clothing, but being out in the sun, looking after animals, looking after crops all day, and then going in at night and coming out again at dawn. But now, I don't know how often you go out in the sun. I'd say I probably get less than 1 minute a day, and especially if it's cloudy. I'm on a computer all day. So it's not surprising we're all deficient. And it gets worse because we now cover up and put suntan cream on ourselves because we know that we're so pale, if we go out in the sun, we're going to get sunburned because we're not used to it. And, you know, we wear a bikini. Well, we're crazy. We're all crazy. And we know that if you're getting rickets, it's end stage, but you'll also have all these things with the weak muscles, weak immune systems, all the things that the reptiles will get if they don't have enough vitamin D. So maybe we all need a bit more vitamin D. As it happens, with humans, it's really easy. You can just give them a supplement. But how much do they actually need? And this is a good question. The estimates for just the bone health, to stop you getting rickets, was what you get in your vitamin pills. You know, they give them out to ladies who are pregnant, or they give them out, you can buy them in the shop, get about that in a tablet. If you want to get the levels, that if you test primitive culture blood and you see what levels of vitamin D they've got, you need to give them about 2,000 to 4,000 international units a day, which is about 10 times more than the minimum required. But you won't get that with going out for, you know, just a short time every day. You won't get that. You'll only get about 2,000 units if you're 40 minutes in the sun with your head and arms bare. But she's got her legs bare, so she'll make a bit more. And I mean, how often do you go out in June midday sunlight in November? It's a big problem. And when you think how much sun do reptiles need, we honestly don't know. This is my dinosaur. He's not getting any vitamin D, any light, any UV through that window. That's an ordinary double glazed window. He loves the sun, but he needs a UV lamp, so I've got one up there. But every species has got their own requirement, and we don't have a clue what that requirement is because we don't know enough about their sun exposure in the wild. But they know, and that's the key. They know how much sun they need. And if we get the basking right by producing something that they recognise as sunlight, and as long as the UV matches what it would be in the sunlight when they're basking, we're at least beginning to get something natural. Some of them will lie out in full sun, in the baked sun on the equator. Others will shuttle, and others will live in a semi-shade. And the extraordinary thing is that animals do know how much they need. I love this picture. These dogs, they know sunlight is what they need. They don't know about the vitamin D, but they know about the sunlight.
I was going to ask about that.
Yeah.
So Queen Anne leg syndrome of dogs is very, very common in the UK, where the legs turn in.
Okay.
Is that a dog's version of rickets or MBD? Effectively, where the bone's not grown correctly, so the legs have turned in.
I honestly don't know.
It's more than that.
I think it's more than that.
You've got to, before you can establish it in mammals, you've got to look at breeding, you've got to do testing way back,
Yes.
and you've got to test generational as well. Then you can say that this is a sunlight deficiency versus inefficient breeding and breeding where they shouldn't.
Yeah, definitely. The large breeds get something called, what's it called? Is it chondrodysplasia? Where the bones do deform, and it's to do with very rapid growth. It's too rapid for their bodies to assimilate the nutrients. And some of the small dogs, like Jack Russell Terriers, they have patelloluxation, which is the bones are shaped wrong, so the knees slip. There's a lot of reasons, as you say. Rickets is quite unusual in dogs because they have a weird vitamin D metabolism, which they're doing experiments on at the moment. They think that they don't get most of their vitamin D from sunlight, they get it from eating prey animals that have got vitamin D from their sunlight. And it's the same with cats, and it's the same with polar bears, and they're about the only common species that have a weird vitamin D pathway. Horses need very, very little vitamin D. Their calcium metabolism, they can absorb it much better from the gut. So there's differences, there's different species, and this adds to our problem. The funny thing is that humans also know instinctively that they need sunlight, but we've kind of wiped that out by our conditioning and living indoors. But they do know. Well, how can we measure what they need in the wild? Well, without following a lizard for 3 years and mapping exactly what it does, it's actually really difficult, and half the species we keep, we don't actually know how they live. No one's done a decent study on UV exposure, or even light exposure, or even behaviour of leopard geckos, and yet they're the most commonly kept lizard in the world. But you can't go to Afghanistan and study them, so no one's done it. It's really weird, but we keep them going. So what do they get in the wild? So how can we measure it? Well, we measure it with this. And if you haven't got one of these, I know they're really expensive, but they could save you an absolute fortune in UV lights. People used to change their UV lights every 6 months. It's crazy with some of these modern ones. They'll last at least a year to a year and a half. So people are throwing money away. If you get one of these, it'll pay for itself if you've got more than 3 or 4 animals. But anyways, what does it measure? It measures the UV index. Well, the UV index is to do with sunburns, human sunburn. So you think, well, that's crazy. What do I measure that for? Well, the spectrum that this responds to is very similar to the spectrum of the vitamin D synthesis. It's the same kind of wavelengths that cause sunburn that cause the vitamin D synthesis. So that's why you have to be careful in the sun. But it's really useful for us because it's easy to remember. It just goes from 1 upwards. It's very familiar from weather forecasts. And sensible exposure is very similar for humans and animals because we're all animals in that respect. So if you've got a UV index 0 to 2, that's not going to give you a suntan, and it's going to be safe for shade dwellers. And likewise, 3 to 5, that's a nice sunny morning for sunbathing or basking animals. UV 10, if you read that on your light, that's actually really dangerous sun for us. Too much for the reptiles. And if it says UV 20, nothing on Earth will give you a UV index 20 unless you go to the top of a very high mountain and you've got very little air and you take a reading there. So on the ground, that would be really dangerous. So if you see that under your lamps, turn the lamp off. So, but what does it do in the daytime? Because it's not just the light comes on and the UV's there. Because the sun alters its height in the sky. It goes up and comes down again. And it depends, the UV levels in the sunlight depend on the latitude and the season because of the height of the sun in the sky, and also the time of day because of the height of the sun in the sky, but also the cloud cover and the microhabitat. So the latitude and season and the time of day, there are little charts you can see on the internet. For example, in Australia, in Perth, this was in the 8th of December, so that's the middle of their summer. And it starts off at dawn with nothing because the sun's really low, and as the sun rises, the wavelengths get shorter because it's got less distance through the atmosphere to pass, and by lunchtime it's really high, it's extreme. So that's the pattern of light in the day, then it goes down the other side as the sun sets. But you've also got to remember there's clouds. So here's one, that this would be if it was completely clear. This is the prediction of if it was clear, and this is the reality, because clouds have come across and knocked it right down. So instead of going up to 12, it never gets above 8 or 9. So that's that one. But the next one is really important for us, because we have little animals. We are 5 feet tall, 6 feet tall. Animals are usually about 6 inches tall. So if you take a reading of your sunlight at your height, I was getting 6.7 on a lovely June day in my garden. So then I started to drop the meter down to near the lawn. And I've only got to drop it just into the top of the grass, and it's gone down from 6.7 to 2.9, so it's about 3. If I drop it right down into the grass where the littlest animals will be, it's gone down to 0.9. And that's really important because a little animal that's scooting through the grass and it's not sunbathing, that's not getting the UV index of 6.7. So we've got to really think about this before we start blasting them with vast amounts of UV. So this is to illustrate what I think would be a good microhabitat for our lizards. This is a wonderful study by Pete Nunn, and unfortunately we never got it published. We submitted it for publication and they rejected it because they said the manuscript was far too long and too complicated, and unfortunately I couldn't enthuse anybody to make it shorter and rewrite it, and so it all kind of got left. But it's a lovely paper. The red triangles are what the sun did. He went out every day for months, and this was the month of November. He went out for 6 months, and in November he would go out about 3 or 4 times a week, and he'd take readings every hour walking on a path looking for lizards. And whenever he saw a lizard, he'd take a reading out in the full sun, and then he'd go where the lizard had just run away, and he'd take a reading where the lizard was. And what happened was, this was the sun, and you can see most days it went right up, even went up to 16, which is incredibly high. And this is what the lizards did. And in the morning they started out, and they were all basking in the sun. So UV index 2, 4, 6, and then by about 10 o'clock they started peeling off from the sun. They started going into the shade. And look, so if you look at where they actually were, a few little boys, particularly the yellow ones are the males, were out posing, you know, I'm great. But most of them were in the shade for most of the time. So the UV index between nothing and 6, that's kind of good. If you gave them that, that'd be kind of good. So, Gary Ferguson did all this work with this UV index stuff. And what he said is, let's get all the data studies we can possibly do, going around with meters and measuring these lizards, following them around. And they came up with this report, which is the basis of the only knowledge we really have on this. 15 different species he followed around, and he discovered, to his surprise, that you could kind of classify them into shade dwellers, partial sun, open sun, or midday, just by watching them. And lo and behold, the UV index they got over a period of a day would fall into these groups. So an average would be that, and the maximum he ever recorded for the species would be that. So for example, one of these species, unfortunately I haven't got the figures so I can't tell you which, the maximum they ever saw was 1.1, and one of these species, the maximum they ever saw was 3. So that gives you a kind of a handle on the maximum, and that gives you a handle on the average, which included the times they're in shade. So we've got the Ferguson zones, there are 4 Ferguson zones, and you've probably seen that. We did a project on it with the Reptile Amphibian Working Group from BIASA. And what we did, we published it, and you can read that online. There are various links to that, but you can read the actual article. And this is what we came up with. We said, look, shade dwellers, crested geckos, leopard geckos, they're all shade dwellers. Let's give them a range in this zone 1. And likewise, occasional baskers, open sun baskers, and crazy animals. And so we put them into these categories. And you might disagree with these categories. They're kind of ranges. And an all-day average for that lot, like shade. So if we're going to give them shade dwellers, let's look at shade dwellers and think those are the sort of ranges we want to give them for their everyday life in the basking areas or in the warm areas. The one-off maximums, the maximums, we don't want to go above the sunlight maximums. Those would be the absolute maximums for the sunbathing. And people seem to think this means the range they have to have. But these are maximums, so that's, you don't want to go above it, rather than we want to give them it. Do you see what I mean?
That is surprisingly low for a beardie.
Yes.
Like 1.
Well, hang on.
Just like, yeah, it's
Well,
kind of normal. Daylight is 1 to
Beardies
3.6.
are
Yeah,
3.
so, but,
Oh, this
yeah.
one, this you wouldn't use the shade method. You'd always give them a sunbeam because
Right,
they're sunbaskers. Do you see what I mean?
Yeah, yeah.
But yes, if you were going to give them an all-day, it goes up to 2.6, but it wouldn't be really sensible because they don't live in the shade. They need a basking spot. So what you tend to do is to have a basking spot. I reckon 3, 4 is perfect. And then they can move into that shade whenever they want. So over a day, the average might be between 1 and 2. Are you with me? The average is 1 to 2. The basking spot can be 3, 4, with an absolute maximum around about there. That's how we made it work.
On the
Choosing a lamp. again, it's all very quick. It's all very generalised, and you've got to let the animal decide what it wants to do. That's the key. The animal knows. I might not know, but the animal will. So if you give it too much bright light, it's not going to come out. It knows it's too much. And you've got two basic types of UV light. You've got the fluorescent tubes in the compacts, which have got a lower output and an unfocused beam like this, all the way around, unfocused beam, low level UV. You've got the mercury vapours, the metal halides, the T5 high output tubes. You see, people say, what's the difference between a T5 and a T8? Huge difference. And you've got the metal halides. So you've got two different types, and that's really handy, because you can say that these are like shade, so you can put them low level UV over a larger area for your shade dwellers, or you can have like sunbeam, where you've got the more intense light for a hot bathing spot for like sunlight. So that makes life an awful lot easier. You've got the shade. This is your typical 10% UVB tube, and it's all to do with distance. People say, do I use 5% or 10%? The only thing I can say is how far away is the animal, because you can use a 10% tube at a foot away, or you can use a 5% tube at, I don't know, 5-6 inches away. The only difference is the distance in that case if the spectrum is the same. So this is a D3 tube, a T8. This probably it's almost the same as this tube. And you can see that if you've got within a ridiculously close distance of it, you could get your UV index of between 4 and 6, like 5 centimetres away. So 10 centimetres away it's dropped down. By the time you get to 30 centimetres, you've only got a UV index of 1. So that's a pretty nice tube for a gecko, a ground running gecko that can't get up too close. You approximately double the light that reaches the animal. And I can just show you that, because here's your tube. And if I put a reflector on it, there we go. How many tubes can you see? 2, 3? You can see 2 tubes. So you get double the UV, because it's picking up the stuff from the back of the tube and reflecting it forward, just like another tube. And aluminium reflects about 99% of UVB, so you've got nearly double the amount of light. And if you do it with a T5, this is the most extraordinary thing. Because the T5 is such narrow beam, and you get a parabolic reflector like this, you should be able to see 3 tubes now. And you get about nearly 3 times as much UV with a reflector on as without. And that makes that a very, very powerful UV transmitter. And I've done some of these charts. I've actually got the real things here. I used to colour them in, because I was like that. And here's the one with no reflector. That's the same as that one. And you can see it's really low. UV index of 1 is only that far away. Put a reflector on it, and the UV index of 1 is now that far away. Okay? If you get a T5 and you put a reflector on it, this is what you get. I love this. I had fun making this. So that's a T5 with a reflector on it.
And how big is that? 4 foot? No, 3 foot.
Well, that's pretty damn good, because your bearded dragon.
That's full size.
Yeah, that's actually life size, because I put the lamp here. And
That's the smallest T5.
yeah, that's a little 2-footer. That's that tube actually with the reflector. I don't think it's that actual tube, but it's the same as that. So you've got your beardy about a foot away, getting your UV index of 3. But if you had a really big enclosure and you had some leopard geckos, you could put your leopard geckos down on the ground down here, and that would be fine for them. But you wouldn't want to put your leopard geckos with that if they were only that far away. So you see how it works? That's how it works. Right.
Sorry, generally that kind of lighting would be up above them.
Yeah.
Would there not be benefit to putting a UV tube 3 inches or 2 inches above the bottom of one of the sides, so it radiates out horizontally, and then the animal can move closer or further away from it?
Theoretically, I can see what you're saying, but the glare in its eyes would be totally intolerable. Because the sun is above, and if you think about an animal's eyes, they've got, a lot of animals have eyebrow ridges or eyelids, and the whole point of the eyelids and the eyebrows and the ridges is so that the sun above doesn't go through into the pupil and hit the back of the eye. Whereas if you put the tube there in front of its face, all that UV is going to go straight through its pupil and hit the retina, and that is really bad for their eyes. And also the glare, because I don't know about you, but I can't bear driving into the sunset. So that would be why I would say you have the light above, because then it's not going through into the animal's eyes.
So a lot of animals' profiles are set up for being under the sun as opposed to next to it. You know, if you look at the side of a beard, it's like, whereas from the top, you've got a lot more surface area.
And then also they're more flatten and they'll turn at the angle, so it can be at an angle, but if it's on the eye level, I think it would be quite distressing. And also you don't really want it too close, do you? I mean,
it's quite interesting that how it has moved on, because initially when we first saw babies in this country, well no, people were telling you to lay the tubes on the floor.
I know.
And the animals were running on them. The animals were running on them and obviously running off.
Yeah.
But that was the way initially we were instructed to get the UVB into the animal.
Back then as well, the tubes
But this is why.
No, not so powerful.
You're absolutely right, because this is why.
Yeah.
These little tubes, these are the most powerful things we had.
Yeah.
5 or 10 years ago, this came out, this was the D3 12%, and that everyone was going, wow, that's really powerful. But, I mean, it's not really powerful at all. So you put it 6 inches away, because that was how close you needed to be. But we've now got stuff that's so much more powerful. They're now saying these 14%, and they're too much. You don't need a 14% in a tank that's only 15, 16 inches tall.
The way they're marketed is that they're for bearded dragons, and that is what's needed.
Theoretically, if you actually read what they put on the original documentation, they said for tall enclosures, they need to be at least 2 foot away. You know, but people are putting them in and swapping them for their T8s. You know, it's
I know a lot of people are using chameleons on that.
Too much.
I know
too much.
they're letting them get rid of both and stuff.
Yeah, well, it's too much. But anyway, let's just quickly go on. This is the 10% with a reflector with a compact lamp. Now, compact lamps are fine if you want something that's got a small area, very small area, and it's very concentrated close to. Very, very concentrated. It will go up to UV index 10, 15, 20 of 5 centimetres away, but only another 10 centimetres away, and it's really low. And that means that they're quite tricky to use. I use the, which is a lot weaker than some of these spiral ones, because you can put a mesh underneath, and you can have it far enough away from the mesh to make a small area for an animal, an arboreal animal that can climb up. But you have to be very careful that it doesn't hang underneath the mesh, and you've got the mesh too close to the lamp, because then you'll get this very high UV there, which you really don't want. And you can get nice low levels in a small little exoterra or something. But people use them for bearded dragons. It's crazy, because the bearded dragon, you know, it's dangerous if it's too close, and it's nothing if it's further away. So they're very limited use, but people will sell them with pictures of bearded dragons on the box, which is, you know, that kind of thing is popular, I think. Metal halides are lovely. The light is beautiful, but unfortunately most of them don't hold the UV for very long. This is the new Zoom-made Reptile. And the lovely thing about this is metal halides need a ballast. So you can buy a separate ballast and use a lucky reptile, for example. You've got this ballast box, and there's fizz and the light comes on. This is the ballast is in there. So it's not a self-ballasted lamp. The lamp, this is the ballast here and here. So it's really nice because you can just hang it up, plug it in, the little ballast lights up, and it lights up the lamp underneath. But the problem is, the UV is really weak and it disappears after a few months. So this lamp's been used for, I don't know, probably a couple of months now. I've tested it, and then I started using it for just lighting up. And I have to use it with a T5 for the UV, because the UV is almost gone, but the light is lovely. The other problem is if some of them have got high UV, but the beams are quite narrow. So if you've got a bigger animal, it's hardly going to get in and out of that beam. It's a big problem. I would love them to solve this problem, because I think metal halides are lovely. But the UV from the metal halides is kind of a bit tricky. Mercury vapour lamps, the spectrum is horrible. They've just got spikes in 4 different colours, purple, yellow, which is why you get that funny green cast with them. And I don't know what colour they look like to a reptile, but they do produce quite reasonable UV. And if you get one with a pearl face, it'll spread the beam very wide like that, complete circle beam. There's no problem with them except the light just isn't what. There are better things, is what I'd say. They still sell very well. And we've got the T5s. Now, I really like these T5s. There are only 2 companies that make them with really good spectrum, and that's Zoomed and Arcadia. Zoomed have had a little bit of a hiccup. They changed factories about a year ago, but they've gone back to the original factory. So the ones I just finished testing are just back to the normal specs, and they're virtually identical. So, if you get them fairly soon, the new ones coming through, they're the same.
So are you seeing any differences between the Arcadia and Zoomed, or are they giving the same?
The ones they were using quite recently were a lot lower. The output was a lot lower. I did a report and measured them. But now, the new ones that are coming out now are back up to the old specs. The spectrum was the same. They got the spectrum about right, but the output was much lower. But now they're back up again. That's why on the forums you see people going, you've got to use the Arcadia, but the Zoomed now are going to be the same.
Okay.
So we've now got all 3. Got the heat, the light and the UV. And don't forget the humidity. We haven't even touched on humidity, but the humidity gradient will always follow because infrared is a very good drying agent. That's why I use it for drying out things. And you'll find that the humidity in your cool end is always going to be much higher. If you have a hot infrared lamp, you can get the humidity down to like 5-10%, which is really low. And you can still have it if you've got a cool end, which is a little bit more moisture. You can still get it 50-60% in the cool end. So you just have to be aware of that. The lights. This is a lovely diagram. This was Matthew Versawell from America did this for the forums, and I think that just sums it all up nicely. You've got your UV from that, you've got your halogen lamps for the heat, and you've got your metal halide for the really bright light. You put extra light in the cool end, not UV, that's just ordinary light. And you've got to overcome some barriers. So, first of all, glass. Let's run through this. Ordinary bavarian glass blocks 98 to 99% of UV beam. So you need to buy, if you're going to buy glass, you need to buy UV transmitting glass, which will transmit up to 50%. Pilkington's Opti-White, for example. These are a high quality glass from glaziers. And you can actually buy it, can't you, Ron, from ordinary glaziers.
They use them in double glazing units to make the unit more efficient. And then they put a UV block on. So if you get into the glazing agent, just get the Opti-White without being tarted up.
Yeah.
It's really it's relatively cheap as well.
You must ask for the UV transmitting one because humans seem to be so terrified of UV that they put block on everything.
So is this the glass that your dome's made out of?
I've got one.
Yeah, this is the glass I need to replace in my greenhouse.
There's Asahi glass, which is the same thing, but made in Japan.
Yeah, but there are lots of different companies. Planibel, it's something called Planibel, isn't it? But there are quite a
Asahi, it's Asahi, isn't it?
Yeah. There's quite a lot of different brands. I just chose that as an example. Then you've got acrylic sheeting. It's getting quite popular. Very, very impact resistant. It can be brittle, but it's very impact resistant. And there is acrylic and polycarbonate. On the whole, they have UV block. Polycarbonate blocks it per se. Acrylic doesn't naturally block UV at all, but all the acrylic that you buy, you see acrylic sheets for things, they've all put UV block into the mix so that it doesn't let UV through, unless you ask for UV transmitting acrylic, which they use for sunbeds, because obviously it wouldn't work if it didn't. And that's Baines Plastics is a British company that will cut sheets of this UV transmitting acrylic for you. They'll cut it to size. There are other companies, they're quite hard to find.
One in Weybridge.
Is there?
Yeah.
Excellent. So You need to ask around.
They are actually perspex. They are actually
Yeah,
the people who
perspex.
own perspex.
Oh right, brilliant.
Perspex distribution.
Have we got a website? Have we got a website?
Up here, yeah.
Let me have it, because that's another thing to add to the
He
arsenal.
works for them.
Yeah.
I work for them.
Oh, fantastic. Yeah. Let me
So as
have it.
soon as you saw acrylic polycarbonate sheets, I was like, when you said impact resistance, iron 30
Yeah.
is impact resistant.
So, this is a piece of Bay Plastics UV transmitting perspex. Good stuff. It scratches, so a lot of reptile keepers don't like it because it's scratchy.
Oh, exactly.
But
Yeah, it's polycarbonate.
it's acrylic. It's perspex.
Triple, that'd be 000.
Yeah, it is. It's XO whatever. It's the same as that. Is that?
Yeah, that's oxide. Yeah.
There you go. That. And rub lids. Please don't tell me you can't give your snake UV because it's in a rub. This rub lid transmits about 50% of the UV. Now it will go yellow over a longer period of time if you've got a strong UV on top. I put a UV index of 10 against that for 100 hours and I could barely detect the difference with the meter, and that was UV index of 10, which you certainly wouldn't want to put on any animal. So you can use a rub, you can put a low level UV, but the problem is getting the gradient, because in a small rub you have to put the tube up one end and have plenty of shelter, because animals have got to be able to get out of the light and the UV. A small rub you couldn't really use a tube across, it would be just horrible.
You said it transmits 50%, but that's 50% through, but you couldn't tell the difference in the
Yeah, what I did, I covered this rub lid, I tested this rub lid and I could measure the transmission. Then I covered half of it with black paper on both sides so that there was absolutely no light getting to this plastic, and I exposed this to UV index 10 on this side for 100 hours. I then took all the black sheeting off and I put it under a lamp, first under this one and then under this one, to see if there was a difference, to see if it had decayed, and I could barely tell the difference between the one that had had no exposure and the one that had exposure. So this thickness of rub, this size of rub, let through about 50%. Now we had a test when we did the AHH meeting where, was it Francis, brought a whole pile of big rubs, some of the other different sizes, and some of them have got thicker plastic than others. So if you've got a UV index meter, you would need to check that your rub is the thickness and the sort that will let some UV through. So I'm not just saying they'll just buy a rub and stick it over, but if you've got a meter and you've got a rub and you've got a UV tube, why not give it a try and see what you get? Because
the other thing I would add, Fran, is that the rubs are probably made in more than one factory.
Yes.
And the mix of plastics might be different from factory to factory.
That's
so
possible.
I mean, your point is very important.
This was the really useful box company.
First.
You know, there's supposed to be the company, isn't it? Really useful box company.
Yeah.
But I don't know what other folks use. What do you think? What's the plastic? Do you know what the plastic is they use for these?
That would probably be probably some sort of PETG, I think.
Okay. Yeah.
It's a PMMA, it'd be a PMMA.
Right.
Yeah.
Yeah. It's quite soft, isn't it? It's quite soft, greasy plastic.
Similar to a PETG. What they call a PETG.
Yeah, it works.
Very similar.
Works. So it's worth a try, isn't it? Okay. And the other thing is the tortoise people have started using polytunnels, making outdoor enclosures for shelters which let UV through. And polytunnel sheets which UV transmit are now available. And one brand is called Lumisol, one brand is called Sunmaster Clear. I think there's quite a lot of brands coming out with it because they've discovered that plants do quite nicely if you give them some UV. So, yeah. And, who'd have guessed? So if you're thinking about outside enclosures, polytunnel plastic is a heck of a lot cheaper than glass for making big enclosures outside. You do have to watch, though, that you don't seal off the ventilation. They did a little experiment making like cold frames for tortoises, and if you put the cold frame lid down, the heat build-up was absolutely horrendous. It cooked the tortoises.
Remember, it's a kilowatt per square metre.
Yeah, so
And
the
if you
heat was
trap
going
that
through
heat-
as well.
And if you trap that heat, that's
Yeah.
a hell of a heat.
It's a bit like a hot car, putting an animal in a hot car. So, but if you ventilate it completely open at the front, for example, like a little walk-in shelter, you get UV through it. So that's one more little thing to use. Finally, I just want to mention mesh. Mesh doesn't selectively block any wavelengths. It blocks visible light, it blocks UV to the same extent because it's a physical block. It's like a little frame of metal that's just blocking the light and blocking the UV. And you can measure this quite easily by just putting your tube behind it, and you can see that it's blocking little squares of black, and where those little squares of black are, of course the UV's not there. So you can tell, you can actually work out a little calculation of how dense the mesh is as to how much UV light you're going to lose. And obviously a wide mesh, ideally with a thinner bars than this, is going to let a lot more light through than a very fine mesh like this fine screen mesh. But again, if the wires are very thin, you may not lose as much as you think. So you can see there's quite a block on there. It's quite a lot less light coming out because it's just physically blocking it. So you do need to work out, if you haven't got a UV meter, you have to allow for the animal to get a bit closer.
I think I mentioned this one before. We have a paper on AHH.
Yes.
So they found the correlation between the drop-off was actually the wire thickness, not the hole size. So it had nothing to do with the hole size whatsoever. So you have the smallest hole imaginable. It was all about how thick the wires were.
Yeah.
They caused the UVB attenuation. Yeah.
Blocking the light. And it doesn't block the wavelengths because they're so small, they're going straight through. It's blocking the physical. The UV is blocking, it's a physical block. It's not a filter. So how do you measure it? We've got all these different meters. They all do different things. The infrared meter actually, as Ron's pointed out, is not looking at the red light, it's looking much further down, but it's still measuring the temperature. The lux meter is measuring visible light in the human range. The UVB meter, this old solar meter 6.2, is measuring the whole of the UVB, and it will actually measure into the UVC, and it will measure a little bit into the UVA, so it's a complete total. Whereas the 6.5 meter's got a filter, which filters out some of the longer wavelengths UVB and UVA, so it's actually just looking at those short wavelengths for vitamin D, which is why it's a better meter to use than the 6.2. When you're using the stuff, this is so simple, I really shouldn't be showing you this, but sometimes you get beginner keepers in my talk. You've got to aim the sensor at the hot spot for an infrared thermometer. And the closer you are, the better the ratio, the better the pickup to get the temperature. Otherwise it's measuring the temperature to each side as well. Hold this thermometer close. Be careful not to shade it with your hand because you do need to measure the temperature with the infrared. And press the button to reading. But the UV index meter is opposite. It might not sound obvious, but I've had people aim the UV index meter at the substrate. It doesn't work because you only set the light source. So you only use up here. And there's the sensor there. And if you've got one with a cover on, I had one lovely person, she came in, she says, it doesn't work, I've tried everything. I said, well, feel like that. The poor woman was quite embarrassed. But I'm sure none of you will make that mistake, so you aim it at the light, and if you want to measure it regularly, press the back button, take the reading. If you monitor your decay, take the reading from exactly the same place in your viv every month, and you'll be able to monitor the decay. And if you want, ideally, take it where the animal sits, the one spot that the animal likes the best, and then you'll get the decay at his level. Lux meters are a pain because they're exactly the same as an ordinary meter. You just put the sensor aimed at the light, take the reading. But those meters have got different sensitivities, and people find it really confusing because a good one will have 3 different sensitivities. And it'll, on the lowest settings, you'll get lux, but it'll max out if it goes over, say, 100. So then it will just show 1. So what you have to do is then take it up to the next highest range and mentally add a 0 to the reading. So if it was going to say 1,000, it would just say 100, and you add the naught. And then you click it up another one, and it'll say 100 when it's actually 10,000. It's gone up another notch. But people find that really confusing. But unless you're going to use lux meters, you probably won't have that problem.
Fran?
Yes.
It might sound like a silly question, but with the UV meter,
yeah,
does the reading take into account the actual height of the meter itself? Is the reading coming from the base?
No, coming from the sensor.
So it's coming from the top.
Yeah.
So then
it's measuring the UV at the sensor, because the electronics is just underneath the sensor.
Right.
But it's calibrated, so it's measuring it at that point where the sensor is.
So that wouldn't give you an accurate reading, for example, if you were trying to take a measurement from
ground level. No, it's an absolute pain. And Gary Ferguson, who's doing all that work with measuring the animals, he begged them to make him one where the sensor was detachable, so he could poke it down holes and things like that. And they tried, but the amount of light, the amount of UVB that's in that wavelength is so tiny. I mean, it's minute. The electrical impulse is so tiny that they turn the gain up really high just to get the electronics to work. It's microvolts, isn't it? I wouldn't even know. Millivolts.
So it's microamps, yeah.
And so it was impossible, because as soon as you made the connection longer than that distance, the interference and the white noise just messed it all up completely, and you couldn't get a reading off of it. And he never worked out how to do it, so we haven't got one that you can attach the sensor. And it's an absolute pain, because if you want to measure the height there, the only way to do it is to move the lamp over the edge of something that you can do it, and then take the reading and assume it's the same a bit further around. Absolute pain. I totally agree.
It's showing like put the sensor on the side instead of the top.
Yeah, exactly. There's so many ways of doing it, but
put it on the same side as the screen.
I mean, to be honest, in the wild it works fine, because the animal's only got to move 4 inches. I mean, an animal will move 4 inches in a second.
It's also true, Fran, that the angle of attack on the sensor is fairly wide.
Yeah.
So if you've got it like that and you intrude on it on the side, you're actually impinging on the light that's being measured. Because the infrared, the ultraviolet is coming at it, not just straight, but it's all coming.
We need to finish. Because we're very fast running out of time. Just a few pictures to finish off. How you can measure on what I do. I measure the charts and then I overlay them with the same sort of scale, so you can kind of get an idea of what you're getting with your animals if you do this. But I'm obviously not going to do this, but just to give you some ideas of what you can do with the little lamps and small Bavaria. And then in the zoos you've got these big units with 5-6 tubes in, and I've done measurements on these, and look, this big thing has got 6 54-watt tubes in, and you can get UV index right down 4 or 5 feet for a Komodo, or you can get it right down to the ground level with these big 8-tube things at Chester Zoo. Again, you wouldn't want the animals to be up here, but they're not, they're all down here. And likewise, Bristol and Crocodiles of the World. So he's got one of these, they're all sitting under that. And you can use the T5 light waves, I've got one there, for a bigger enclosure. You can use gentle ones for an amphibian. You put in about 1 or 2 UV index tubes and use the rest for bright white light, and you can get a really nice low level fade. And this is my favourite picture. This is the one at London Zoo. They've got 4 6-tube units, so that's 24 tubes, 54 watts each. So there's a lot of power, and there's a panel heater there as well. And these huge animals are getting UV index of about 3 at shell level. And I measured it, nearly killed myself, it was so hot, but I was under there measuring it around on the ground. So I was doing a floor measurement. And actually what I did was I had it on a little tripod, so it was approximately the height, going by what you're saying about this, I had this at about the height of the top of the carapace. And I was measuring something that's about, UV index of 3 was literally about 4 meters wide, which is massive. So if you've got a big enclosure with a monitor or something big, have a look at this. A cheapo T5 hydroponic unit used for growing, well, you know. And all you do is you buy one of these and you fill it up, you take the lamps out that's in it because they're just ordinary plant lamps. They're nice and bright, so if you don't want high UV, you can leave them mostly in and just put one in. Or you can put 4 T5 high output Arcadia tubes in this, and you can hang it like this, and you'll get absolutely massive UV under it, and lots of bright light as well. And you just put a metal halide or LED or something right next to it to make a basket spot, and you're all settled. And you can get these in all sorts of sizes. You can get one with 4 tubes that's 2 foot. You can get one that's 4 tubes that's 4 foot. You can get one that's 8 tubes that's, you can't get one that's 8 tubes that wide, but you can get an 8 tube one that's 4 foot long. So we've actually cracked it quite a lot by doing that. And that's about it. So I'm afraid we've overrun. It's 9:15, but thank you.